Good morning, students. I am Sweetly, Assistant Professor of Civil Engineering Department, working in Emmanuel Arsa JJ College of Engineering. Today, we are going to study about the principal stresses. In order to know about the principal stresses, first we have to know what is meant by principal plane. The plane which have no shear stress is known as principal plane. Okay, if any plane have no shear stress, then it is known as a principal plane. Therefore, in this principal plane, only normal stresses are present. The magnitude of normal stresses acting on a principal plane is known as principal stresses. Is it clear? The magnitude of normal stresses acting on a principal plane is known as a principal stresses. There are many conditions for calculating the principal stresses. If a member subjected to direct stress in one plane, then the formula for normal stress and shear stress become different. Based on the condition, we have to apply the formula. If a member is subjected to direct stresses in two mutually perpendicular direction means, therefore, in that case, we have two stress value and the formula get different for both normal stress and shear stress. Same like that, if the shear force is given, then you have to apply that formula for normal stress and shear stress. When a member is subjected to simple shear stress means one type of formula. If a member is subjected to a direct stress in one plane and a shear stress is also accompanied with it means the formula becomes different. Based on the formula and the condition, we have to calculate the values. Shall we move through the example? See, here the question is, the mild steel block has a cross section of 50 mm cross 50 mm, carries an axial load of 35 kN which is compressive in nature. Find the normal and tangential stress across a plane through a point at 30 degree to the axis of the block. Also find the maximum shear stress in the block. What is given in the question? The mild steel block having a cross section of 50 mm cross 50 mm, which means the area of cross section value is given. Therefore, how we calculate the area? 50 cross 50. The value is 2500 mm square. Carries an axial load of 35 kN, which means the load value is given. How you indicate the load? We indicate the load as capital P. Okay, the capital P value is given as 35 kN, which is compressive in nature, which means the given force is a pushing force. If the value is tension, then it is a pulling force. Okay, I hope you understand. Compressive force means pushing force, tension force means pulling force. Here the axial load of 35 kN is compressive. Therefore, you have to take P is equal to 35 kN. Then find the normal and tangential stresses across a plane through a point at 30 degree to the axis of the block. Here the value of theta is given as 30 degree. Then they asked to find out the normal stress and tangential stress. Tangential stress is also known as shear stress. Okay. Also find the maximum shear stress in the block. Therefore, you have to find out normal stress, tangential stress and maximum shear stress in a mild steel block. Is it clear? In the given data, area is given, axial load P is given, theta is given. To find normal stress, tangential stress, maximum shear stress. Okay. Now, normal stress is indicated as sigma n, tangential stress is indicated as sigma t, and maximum shear stress is indicated as sigma max. Therefore, we know that here only one load value is given. Okay, only one load. Therefore, here the stress is acting in only one plane. You have to apply the formula for normal stress as sigma n is equal to sigma cos square theta. For that formula, we need the value of sigma. Okay, here the sigma value is not given. Instead of that, they give the load value and area of cross section value. As we all know that, what is meant by stress? Stress is defined as a ratio of load by area. Okay, resisting force per unit area is known as stress. Here the load value and area value is given. Substitute the value. You get the answer as 40 Newton per mm square. Here the value is given in kilonewton. If you want to convert, you have to convert kilonewton to Newton. 1 kilonewton is equal to 1000 Newton, or otherwise you have to substitute it as 35. Then you get the answer in kilonewton per mm square. Okay. Then substitute the value of sigma in a normal stress formula. Sigma n is equal to sigma cos square theta. Okay, sigma value we already find out 14 and theta value is 30. Therefore, the answer is 10.5 Newton per mm square. Then we are going to find out the tangential stress. What is the formula for tangential stress? Sigma t is equal to sigma by 2 sine 2 theta. The value for sigma is 14. Substitute that in place of sigma. Therefore, we get 14 by 2 sine 2 into the value for theta is given, that is 30 degree. Therefore, 2 into 30. Substitute the value and find the answer for sigma t. The answer is sigma t is equal to 6.062 Newton per mm square. Then they asked to find out the maximum shear stress. The formula for maximum shear stress is sigma by 2. The value for sigma we already find out as 14. Substitute it. 14 by 2 is equal to 7. Thus we find out normal stress, tangential stress and maximum shear stress. Okay, here is the result. I hope you understand. Next we are moving towards the next model example. Here, read the question. The principal stresses at a point in a section of a heat exchanger shell are 18 megapascal tensile and 10 megapascal compressive, acting mutually perpendicular to each other. Determine the normal, shear and resultant stress intensities on a plane whose normal is inclined at 60 degree to 10 megapascal stress. Find also the maximum shear stress. Here in the question they give 18 megapascal load and 10 megapascal load acting mutually perpendicular to each other. Therefore, here two force values are given or two stress values are given. Okay, megapascal, it indicates mega Newton per meter square. Therefore, the stress value is given. Two stresses are acting mutually perpendicular to each other. Then no other values like shear stress is not given. Okay, therefore you have to take the formula for normal stress and shear stresses. The stresses acting in two mutually perpendicular direction, that formula you have to take. Okay, here the theta value is given because it is inclined at 60 degree to 10 megapascal stress. Here you have to draw this diagram. How you draw this diagram? You have to draw one member. Okay, first you have to draw one rectangular member. Here the force values are given, stress values are given, it's a stress. 18 megapascal stress is given. It is a tensile. What is meant by tensile force? It is a pulling force. Okay, therefore tensile represents the pulling force. Therefore you have to mark 18 megapascal as a pulling force in the axial direction of a member. Okay, then 10 megapascal load is acting on the transverse direction of a member. Okay, because it is a compressive force. Compressive force means pushing force. Therefore you have to apply the 10 megapascal load stress in a transverse direction of a member. Then you have to mark the theta value also in the diagram. Note the point. Here it is given the theta value is inclined at 60 degree to 10 megapascal stress. Here the 10 megapascal stress is acting in a transverse direction, and from that transverse direction the theta value is inclined at 60 degree. Okay, which means the normal shear and resultant stress intensities is inclined at 60 degree. Therefore you have to take the value for theta as 60 degree. Here the force 18 megapascal load is tension, therefore you have to take it as positive. If the stress is compressive, you have to take the value as negative. Okay, when both the stresses are present and acting mutually perpendicular direction, then you have to take the sign also, consider the sign. If it is tension, then you have to take it as positive. If it is compression, you have to take it as negative. Then they asked to find out normal stress, shear stress and resultant stress intensities and maximum shear stress. Okay, how you indicate the normal stress? Normal stress is indicated as sigma n. Shear stress means it is also known as a tangential stress. It is represented by sigma t. Then resultant stress means sigma resultant, sigma RAS, and maximum shear stress is indicated as sigma t max. Okay, solution. First, the formula for normal stress, which means stresses acting into mutually perpendicular direction. The formula is sigma n equal to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta. Already the values are given. Sigma 1 value is 18 and sigma 2 value is minus 10. Okay, don't forget to put the negative sign. You have to put the negative sign because the given stress is negative. Okay, therefore 18 minus 10 divided by 2 plus 18 minus into minus. Okay, minus into minus plus 18 plus 10 cos 2 into theta value 60. Okay, you get the answer as minus 3 Newton per mm square, which means the normal stress is also compression. Okay, compressive stress. Negative sign indicates the compression. Then we are going to find out the tangential stress. Tangential stress, sigma t formula is sigma 1 minus sigma 2 by 2 into sin 2 theta. Substitute the value for sigma 1 and sigma 2. Therefore 18 minus into minus, minus of minus 10. Therefore plus 10 in divided by 2 into sin 2 into 60. The value for tangential stress is 12.12 Newton per mm square. Then they asked to find out the resultant stress. What is the formula for finding the resultant stress? For stresses acting into mutually perpendicular direction. The formula is sigma resultant is equal to root of sigma n square plus sigma t square. We already find out the value for sigma n, that is normal stress, and the value for sigma t, tangential stress value, we already find out. Substitute the value and find the answer. The answer for sigma resultant is 12.485 Newton per mm square. Then what we are going to find out? We are going to find out the maximum shear stress, sigma t max. Sigma t max formula is sigma 1 minus sigma 2 divided by 2. The value for sigma 1 is 18 minus of sigma 2 value is minus 10 divided by 2. The answer is 14 Newton per mm square. Okay, I hope you understand. These are the formulas for calculating normal stress, tangential stress, resultant stress and maximum shear stress for a beam carrying stresses in two mutually perpendicular direction. Okay, to write the result and complete that question. Then we are moving towards the next model. Here the question is, at a point in a strained material, the intensity of tensile stress is 60 Newton per mm square and a shear stress of 25 Newton per mm square. Graphically or otherwise, locate the planes for which the shear stress is 0. What will be the normal stress on such the plane? What is given in a question? Here the tensile stress and the shear stress value is given. Okay, what is meant by shear stress? If two forces acting tangentially opposite to each other, the stress created between that portion is known as shear stress. Okay, what is meant by tensile stress? It is a pulling stress. Okay, pulling force creates the tensile stress. Tensile force divided by area gives the tensile stress. Here the intensity of tensile stress and the shear stress values are given. Tensile stress is given as sigma is equal to 60 Newton by mm square and shear stress value is given as 25 Newton by mm square. Okay, we represent this stress as sigma and the shear stress as q. Okay, they are asked to locate the planes for which the shear stress is 0. Okay, here they give the shear stress value as 0. Okay, the shear stress is also known as a tangential stress. First, the tangential stress on the plane is 0. Then we have to find out the normal stress on such a plane. Okay, can you understand the question? The stress value, sigma value and q value is given. Theta value is not given. We have to find the theta value first. How we find the theta value? Here one condition is given. The shear stress value is 0, which means the tangential stress value sigma t is 0. Okay, by using sigma t is equal to 0, you have to find out the theta value first. Here you have to use the formula for a member carrying a direct stress in one plane and accompanying with a shear stress. Okay, direct stress in one plane and shear stress formula you have to take. Okay, first we are going to use the tangential stress formula because in the question they give the value for shear in the oblique plane is 0. Therefore, you have to take the formula for sigma t. Sigma t formula is sigma t is equal to sigma divided by 2 sin 2 theta minus q cos 2 theta. The value for sigma t is given as 0. Therefore, substitute sigma t is equal to 0 and substitute the value for sigma and q. Sigma value is given as 60. Therefore, 60 divided by 2 sin 2 theta minus the value for shear stress q is given as 25. Therefore, 25 cos 2 theta is equal to 0. Then you have to solve it. 60 by 2 means 30. Then minus 25 cos 2 theta is moving towards the right hand side. Therefore, the sign becomes positive, which gives 30 sin 2 theta is equal to 25 cos 2 theta. Then we know that sin by cos is equal to tan. Therefore, you have to move the cos 2 theta towards the denominator. See, sin 2 theta divided by cos 2 theta is equal to 25 by 30. That is cross multiplication. Okay, sin by cos equal to tan. Therefore, tan 2 theta is equal to 0.833. Then 2 theta equal to tan inverse of 0.833. Theta equal to the value obtained divided by 2. Okay, therefore we get the theta value as 19 degree 54 minutes. Then in the question they asked to find out the normal stress on that plane. What is the formula for normal stress of a plane carrying one direct stress and one shear stress? What is the formula? Sigma n is equal to sigma by 2 into 1 plus cos 2 theta plus q sin 2 theta. All values are known, right? Sigma value is 60, then theta value is 19 degree 54 minutes, q value is 25. Substitute the value and find the answer for sigma n as 69.05 Newton per mm square. Okay, in the question we find out normal stress and the value for theta. I hope all of you understand about the principal stress and the different models of problems we studied under principal stress. Thank you.